for the curve y is equal to e to the 4 minus 3x, find the equations of the tangent and the normal at the point 2, 1 over e squared, and find the exact coordinates where the normal intersects with the x-axis. Okay, so we've got y is equal to e to the 4 minus 3x. If we differentiate an exponential function, d dx of e to the f of x, that's going to be equal to f dashed of x e to the f of x. So dy by dx will be equal to the differential of 4 minus 3x is minus 3, so we get e to the 4 minus 3x, so minus 3e to the 4 minus 3x. When x is equal to 2, dy by dx will be equal to minus 3e to the 4 minus 3 times 2, which is going to give me minus 2 on the top here, so it's going to be 3e to the minus 2, which I can write as minus 3e squared. So this is the gradient of the tangent at that particular point where x is equal to 2. So the equation of the tangent at 2, 1 over e squared, where the gradient is minus 3 over e squared, using y minus y1 is equal to mt x minus x1. So this is x1, this is y1, and this is mt. So we're going to have y minus 1 over e squared, because the y coordinate is 1 over e squared, is equal to the gradient minus 3 over e squared x minus 2. Expanding the bracket, we get y minus 1 over e squared minus 3 over e squared x plus 6 over e squared. It's plus because we've got a minus times a minus. And then we can take this over to this side, and we're going to have 7 over e squared. So we're going to have the equation of the tangent is minus 3 over e squared x plus 7 over e squared. The gradient of the normal, mn, is minus 1 over e m to the t. So we're going to take the reciprocal of this one and remove the minus sign. So it's going to be e squared over 3. To find the equation of the normal at 2, 1 over e squared, where mn is e squared over 3, we use y minus y1 is equal to mn x minus x1. So this is x1, this is y1, this is mn. So we're going to have y minus 1 over e squared is equal to e squared over 3 x minus 2. Expanding the bracket, we're going to have y minus 1 over e squared is equal to e squared over 3x minus 2 e squared over 3. Right, we need to take this over to the other side. So we need to be careful here. So we've got e squared over 3x minus 2e squared over 3 plus 1 over e squared. Now you shouldn't be frightened of this. Just make a common denominator. We've got minus 2e to the 4. Now we've got e squared times e squared, which is e to the 4 minus 3 over 3ae squared. Notice here, it becomes a minus sign because this line here acts as a bracket, so it's minus all of it, okay? So what you've done, you've taken a minus sign out of here. And be careful and think about that in order to avoid making a mistake. So, where this normal meets the x-axis, the y-coordinate will be equal to 0. So we put 0 equal to e squared x minus 2e to the 4 minus 3 over 3x e squared. We take this to the other side. So we get 2e to the 4 minus 3 over 3e squared is equal to e squared over 3x. And then what we're going to do, we're going to multiply by 3. So that means that 3 will cancel with that 3. And we're going to have e squared times e squared, which is e to the 4. So we're going to have 2e to the 4 minus 3 over e to the 4. So the coordinates of intersection will be 2e to the 4 minus 3 over e to the 4, 0, or you could write it like this, because e to the 4 divided by e to the 4, 2e to the 4 divided by e to the 4 is 2, minus 3 over e to the 4, comma 0. Now, if I wanted to look at this using my calculator, so my calculator would start off in this sort of mode, and I would need to select the graphing mode. So selecting the graphing mode, okay, this will come up. I enter my function. You can't just write in e, you have to actually use the calculator. So it's e to the 4 minus 3x, enter. Okay, and then I can enter my tangent and in again as well. I'm first going to put the point on. So if I do menu and then trace and graph trace, okay, I'm not going to do that. So let's just start again. Let's do that later. So let's just enter the function again. So we're going to have e to the power of 4 minus 3x, enter. I'm just going to put the equations in first. So I'm going to do Control G, doing that up again. Right, so I'm going to be a bit careful here. So we're going to have brackets minus 3, this is the equation of the tangent, divided by e squared x plus 7 divided by e squared, enter. So it looks okay. Just going to move that somewhere out the way a little bit. Okay, I'm going to move this out the way a little bit as well up here. Okay, and now I want the normal, so do control G again. Be a bit more careful entering this because it's a bit more complicated. So it's e squared divided by, arrow divided by 3 times x minus brackets 2 times e to the not log, let's just go back, 2 times e to the 4, arrow minus 3 divided by brackets 3 times e squared. Should be e to the 4. So, okay, go to the end and press enter. It should be 3e squared, enter. Okay, so there we got that. Okay, we're only interested in this bit of the graph, so we need to sort of do a little bit of zooming. So do menu, window, zoom. Let's just go for the box first of all and make a sort of a box around here over the bit that we're interested in. There we go. Let's escape. Okay, I'll just move the labels around a little bit. Okay, so if we want change the color of this, if we select the graph and then do right click, which is control menu for you, so if we just do this, I'm going to change the color to the line color to be green. Okay, and we can select menu, analyze the graph, and we want the intersection. No, we want the 0 where it cuts the axis. We need to select the graph that we want. So we want that one. Go to the left, go to the right, and that gives me 1.95, which is the same as the 2e to the 4 minus 3 over e to the 4th. If you can check that if you want to. If we actually want to mark on menu, trace and graph trace, and if I move it down to this point here, in fact if I just put in 2, it will give me that point there. It will give me the point where we've actually drawn the normal and the tangent. Okay, so just going back to this, there's a screenshot of what I've just done. Okay, so there is the point of intersection that we wanted for, and this is where we've actually drawn the normal and the tangent. These are the graphs that we put in.